on this computer. All right, so let's do our overview of 4.1 and 4.2. Well, really, I guess we should mention the 1.2 stuff. And in 1.2, and there's a thunderstorm outside my house. You never know if that's going to kill the power or not these days. So if I suddenly disappear, it's because I lost power. I don't know if you all have that going on too. Yeah, okay. I'm over here on where am I? I'm like right behind Home Depot in the airport. That's where I live these days. Nice. Okay, so we'll be in it together. There's two main, well, there's two things we got to get to. Oh, yay, Detman, Walgreens. Yeah, we're like all in the same neighborhood. We should just go to a coffee shop and do this. Why do this on Zoom? Is there a coffee shop in this neighborhood? I guess a Big B. Just kidding. Let's see. So we need this notion of what's an observational study versus a design study. And these concepts are actually pretty important. Yeah, Big B. Yeah. So an observational study is just you weed through data that's already occurred. So really, researchers have no control over things. They just go out and look at the data. So we could, a common example of this is, say we want to study the effects of alcohol on fetus or on the health outcomes at birth. So if someone's pregnant and they're drinking, what are the effects on the child? If we were to try to do a design study for that, we would get a bunch of pregnant people, and half of them we'd say you drink a 6-pack every day, and the other half we'd say don't drink, and then we'd look at the health outcomes at birth between the two groups and compare them and see, is there different outcomes? Clearly you can't do that because we kind of know alcohol isn't very good for a fetus and an unborn child, and there are defects that have been correlated with alcohol. No one really knows like how much, so the general recommendation is just like don't drink at all ever while pregnant, but there isn't any, we just don't know because you can't really design that, right? That's super unethical, and who would actually sign up for that? So what we do, how we have created a link between alcohol and I think birth defects is one of the common outcomes that occurs when a pregnant person drinks, is we have gone into hospital records and looked at all of the births and collected data from all of the people that gave birth. And those that drank, we find that there are more problems for the baby that was born than those who didn't drink. So maybe we could say looking at records is kind of an idea here. We just observe something, observe data. We don't know treatment is kind of the word there. Whereas a design study, like variables are controlled, and the researchers, we apply treatments, we do stuff to it. Now, here's the thing that happens. We do tons of observational studies because it's the only way to get at it. And we can only claim correlation between variables. Meaning we've observed some sort of effect. some sort of change. One variable seems to be creating a change in another variable. We cannot claim that they cause something. So we really can't claim that alcohol causes birth defects from an observational study. Now, maybe over the years we've done plenty of observational studies, and we can concur that yes, this is a causal effect. Another one that always blows my mind is smoking. Back in the day, they used to prescribe cigarettes for someone that had weak lungs, right? Like they just didn't understand what tobacco did to your lungs and the smoke and whatever. And for years, no one claimed we couldn't create a causal link saying that smoking cigarettes causes lung cancer or throat cancer. Part of it was because tobacco was funding research that kind of contradicted. But we finally, after years and years of research and data and all the rest, we have come to the realization that smoking does cause these things. So I talked too long here on this, but it is a really important concept between these two. And we should never claim that if we've created a correlated link or if we've noted a correlation between two variables, we cannot claim that they cause each other. One thing causes the other. Okay. So the other thing that's going on here is when we're doing these kinds of studies, we often have just two variables we look at, but we can also compare multiple variables. But for our purposes in our class, we're only going to look at correlation between two variables. And so there are two types of variables we have. We call one the explanatory variable. What is going on here? The pen seems to not be working. Explanatory. And the other one is the response variable. So the explanatory variable is the variable we expect to be causing change. And the response variable is the variable that is changing because of what the explanatory variable is doing. Now, when we give you a graph or a table, it is very simple to identify which it is. This is the X variable. This is the Y variable. So in tables, they're always listed like this. X comes first and then Y. If they were listed like this, X is on top, Y is on bottom. And then on a graph, it's X and Y. Always, always, always. When you're reading like a prompt, a word problem, it gets a little trickier because there you have to determine, well, what thing appears to be causing a change in the other thing, or do we expect to be having an effect? Now, the other thing we should note here is in chapters 2 and 3, we've been looking at just one variable and saying, let's measure something in this variable. Go out, collect the data. Let's calculate the measure of center or the measure of spread, or let's calculate the position of a particular data value within this data set. We're now taking two variables and smashing them together. And we're saying, is there an effect between these two, and can we measure it? And so we get what's called these ordered pairs. This is the algebra world. Oh, Taylor, no worries. I have to, and you know what, y'all, I have to go. Keep forgetting. I have to go pick up my daughters at 11. They have a half day today. I'm so happy about that. Or 11:30. Oh, whoops, I missed it. So we'll go for a little while. Then I'll turn you loose on some practice while I go pick them up. It's only like a 9-minute drive from where I live, and then I'll come back and hopefully you're still able to be here, and I'll keep going. I'm really sorry about that. So this is how the ordered pairs look, and so we're looking for patterns, and in all of chapter 4 is about linear models. So chapter 4 has, let's see, we're looking at a linear model. It's written like this: y equals, StatCrunch writes it this way: b plus mx. You may recall that from algebra 1 and 2. This 0 comma b is the y-intercept, also known as the starting value or the initial value. M is known as the slope, and I think your textbook might use A's and B's. Okay, good. So you all know this. This is change in y over change in x. So change in the response variable divided by change in that thing. Related to this is the correlation coefficient. And really, I don't think we need to write any of this down in your personal reference sheets, because it's all on the provided reference sheet. So maybe we just need to go practice. It's right here. So here's R, its correlation coefficient. This is that page 263. Here's how you interpret the coefficient of determination that you don't know about yet, but that's 4.3. Here's the least squares regression line equation, or the linear model. There it is, y hat equals ax plus b, and the slope and all this. And then here's this big correlation is not causation in observational studies, because of those lurking variables that affect both the explanatory and response variables. So, okay, let's not waste any more time on me talking about this, since it's all right there. And let's do the worksheet we're supposed to turn in to me. And that is 4.1 worksheet 2. No, let's do project 4. Let's start with chapter 4, project 1. So I'll make sure we all get here a second. Let's not start with this one. Let's do project 4, chapter 4, project 2. Right. Here we go. Chapter 4, project 2. There we go. This does pretty much all of chapter 4. We're probably not ready for every single piece of it, but I would like to start here. I think this is a good place to start. So I'll dump in chat what we're doing. We're doing chapter 4, project 2. Now, I did not have you collect data. So we're using arm length and height data collected from your class to determine a linear model. I did not do that, but there is data in here that we can use. So sign into your StatCrunch part. Go to the data sets. Don't do that. And do search for arm length. Let me see if that gets us there. There we go. And let's use Shepherd arm length versus height. Here's an old one I use, but let's ignore that one. Let's see if this one looks okay. Yeah. Oh, this is a beautiful data set. Look at that. Lots and lots and lots and lots of data. Okay, so I just searched for arm length here, and then I picked Shepherd arm length versus height. So you all let me know when you're there. Don't forget, you got to do your file and download thing. You all might be getting super good at this now and don't need me anymore, but just in case. Tell me when you're ready to go. Okay, I got 2 out of 6. Yes, I just typed arm length. There you go, 50%. And then I picked the shepherd arm length versus height. So the first thing says we're going to make a scatter diagram. That's a graph, so it's under graph, and it's actually called a scatter plot in StatCrunch. Now, remember, the first thing is always X, the second thing is always Y. So it doesn't particularly matter in this case, but we're going to let forearm length be the explanatory variable and height be the response variable. So kind of what we're claiming here is that the length of your forearm can be used to determine how tall you are, that there's some sort of relationship between there. So from the scatter plot, that's really the only thing we need to select. You can mess with all the rest of this stuff to kind of make it look however you want, but you don't need to. And there is your scatter plot. If you recall how to copy and paste that thing, you just do that copy thing and then paste. There's that one data value that seems to be problematic, doesn't it? A 50 centimeter long forearm. I don't know centimeters well enough to know if that's crazy or not. How are we doing on that? Is everyone good with the scatter plot? I think, how about, can I just let you try this? Tell me what kind of relationship you think there is, or you do it, and then we're going to do the simple linear regression. Well, I guess let me show you that part, unless you already know it. To do the simple linear regression, you go to Stat, Regression, Simple Linear. And here you select your forearm and your height. Oh, yeah, Regan, that's no good. What were you not able to get to show up?
I just typed in arm length in the thing and it said like nothing was like available or whatever. So I'm just trying on my phone and seeing if it's something like that. Yeah, I just literally typed in arm length in the data sets and nothing even came up.
Nothing showed up.
Yeah.
You could try shepherd arm length.
Yeah, and I did that too, and it still
No good.
said like nothing was, I don't know.
Are you logged in?
Yeah.
Okay.
Yeah, it has my email up in the corner.
That's so weird.
Yeah, I'll figure it out though.
Yes, Laura's right. If you're, or do you have, Brianna, do you have a Mac? You have a Mac, so the best way to do this is click Options and Copy, and it pulls this up, and then you right click and copy image. So you got here for you, what is it, the Mac? Yeah, you have to do this for the Mac, I remember, because I had some people in my day class or in-person class have that problem. Then you right click and paste. Did you get it to work, or Brianna, or did you not? This is the worst one for the Mac. So the simple linear regression results, all we need is is this part. We don't need any of that other stuff. Okay, Brianna, do you want to share your screen so I can see what you're doing? Are you willing to do that? It's totally okay if you're not. I just might be able to help better. I made it so you can share your screen.
You went through that second part of the linear one pretty quick. So just to confirm, we're only copying the simple linear regression results, that little little paragraph.
Yes.
Okay, thank you.
You're welcome. I did do that super fast. And notice I clicked, dragged, and selected, and I'm going to do Control C. And then I'm going to dump that mess here. I don't know why this showed up. I'll just delete that. And then the graph. Oh, you're good, Brianna. You're not dumb. I'm with you. It's all these little buttons you have to mash to get it to work just perfectly. Oh, I hear I was like talking about what I did. Let me do what Laura asked again. So for the question 3, you're getting that simple linear regression results. Let me start from the beginning. So you're going to stat, going to regression, and simple linear. From here, you're selecting your X variable and your Y variable. They're the first column and second column. And you're just clicking compute. There's a ton of stuff we don't need. Anything, all these parameter estimates and stuff, we don't talk about that. I did that in grad school. The F-stat and the p-value. You'll learn about p-values later, but not in this context. All you need is this top part under the simple linear regression results. And I'm just holding my mouse down and dragging to do this selection. And then for your PC users, you're doing Control C, or you could right click and say copy. For your Mac users, you're doing Command C, or right click and copy. And then you're pasting those results here. Now this says paste the graph here and resize it to fit the page. Well, see this little arrow down in the bottom right corner, and this is page 1 of 2 is what that's saying. If you click over, there's the other graph, or there's the graph that contains the line and the point. One of the nice things about this graph is if I put my mouse over it, it shows me the equation. There's that y equals b plus a times x equation. It's also right here, but it's a little harder to understand until you get comfortable with what that's saying. So Mac users, you're going to want to do options, copy, and then copy image, or that's probably best for everyone. It's probably just the easiest way to do it. And then paste here. And it says resize to fit the page. I guess this does need to be resized quite a bit. There we go. And now I got the graph. What did you all say up here about this graph in terms of the relationship? And when we talk about a linear relationship, you should be stating 2 things: the strength and the direction.
Would that be a moderate positive?
That's a good guess. I definitely agree with positive.
Strong? I mean, I know it's positive, but it's just a constant increase. So would that make it the moderate, and then more of an incline would make it strong?
Well, so looking at a graph you're never going to be very good at stating it, or I shouldn't say that. Looking at a graph is very subjective about whether or not it's strong, moderate, or weak. Definitely positive, because if we look at the graph with the line on it, this one, you can see that that's a positive slope. So totally agree with the direction. What you're trying to determine for strength is how close are all those blue dots around the red line. And it could be moderate, it could be strong. I mean, this one's pretty far away, this little one right here. And this one's kind of far away. The way to know is by looking at the R value. That's how we're actually going to know the strength. So up here, you're guessing. There's really no wrong answer. You're just like, oh, it's positive because the points seem to be getting bigger. As X gets bigger, Y gets bigger. They seem kind of close together, so moderate or whatever. You can't get that wrong. And then, yeah, Emily, I don't disagree with you putting a line in there. You know, they seem kind of all over the place. But this correlation coefficient right here tells us what it is. So let me just make this a little bigger. There's the number we look at. And we go here and we say, oh, moderate is between 0.5 and 0.8. So, whoops. So based on the correlation coefficient, this is at the very low end of moderate. It's just about on the weak side. So none of you are wrong in what you set up here. That's good. You're just kind of reading the graph. We don't really read a graph. We look at it and we're like, oh, it looks like this. And then we go read the correlation coefficient. And that tells us for real this is the measure we're really going to read. Good. Does that make sense, or is that too much crazy talk?
So it was weak because it was just over 0.5.
Just over 0.5 puts it in the moderate.
Or moderate, yeah, that's what I meant.
Yes.
Thanks.
You're welcome. Okay. So I've got like 10 minutes before I got to get out of here, and then I'll go pick up my daughters, and the pickup line can always be wild. So what I also want to do is give you the other thing I want you to work on. So I'd like you to, can we finish this? You know what a correlation coefficient is. I just showed it to you. Here you're just saying whether that supported your guess above. You don't know the coefficient of determination yet. It's the R squared value. So this right here is R squared. StatCrunch doesn't label it as such, but it is the coefficient of determination. Do you see how I'm making this bigger? So you all can actually read it. Make it bigger so you can read your stuff. So there's that. And then you're interpreting that value. We can pause on that. You can state the equation, I think. And I think you all are good at it. I would love for you to try the slope and the y-intercept part. See if you can figure that out. Okay, so I'm going to have you do that. And then the other thing while I'm gone, if you finish the project, is, let me make sure I get the right one. Just a second, Brianna. Let me look at this before I forget, and then I'll answer that. 4.1 worksheet number 4. Okay, so back in number 3, once you've got the graph there, you're then just telling us, stating the value of the linear correlation coefficient with 3 decimal places. And that's what I've made big here. So 0.509. And then you're saying, hey, did that number, which you looked at your scale, did that match what you guessed to be the answer back here? The linear relationship just from looking at a graph without a line on it. Well, no, for one, the graph for 3, the graph you're grabbing is the one that came. So you got this simple linear regression output, and on the second page, down in the bottom right corner, there's this blue arrow. You're clicking that, and you're using this graph because it contains the regression equation in it. It also has a different scale than the original one you graphed in there. So the other worksheet I want you to work on if you need more time while I'm picking up my daughters, I'm hoping it'll go really fast, you all. I feel is this one, the 4.2 number 4 worksheet. So I'll just dump that in chat. 4.2 sheet number 4, the chapter 4 project 2. I'm going to pause the recording. Well, first I'm going to stop sharing my screen. I'm going to yeah, sorry, Taylor. I'm with you. Did we go through all we did all the answers up here? Good. And we got this. Was everyone happy with the 2 algebra problems? This one is like plug and chug, which is the simpler one. This one is the solving one. I can show you a trick to solve these. I don't know if it's not a trick. I can show you how to solve them graphically. So we could do y equal, so we've got these 2 things, right? We got one side of the equal sign is this, and we got the other side of the equal sign is this. So in Desmos, we could graph y equals 1.5 and y equals negative 0.05x plus 5.3. And then the solution is where those 2 lines cross. There it is, 76. That's a graphical method of solving algebraic equations. You are more than welcome. See, Emily, to use that method to solve if you want. That might be more confusing than anything else, and so then ignore that. What can make this difficult is finding where the 2 lines cross. Does everyone remember the residual formula? And
That's
also,
where we left off yesterday, and we were like
Okay.
just filling in the definition or whatever for it, but we never got to actually try it, I think.
okay, so maybe we should pause here and pick this up on Monday after you've gone through those notes. Or what would you all like? We do need to go back and do the questions on 510 that you all have. But it might be worth just finishing this up on, wait, is today Wednesday? Yeah, finishing this up on Monday. And we will
I'd
just,
rather wait to finish it also.
yeah, okay, that sounds great.
Same.
Eric, what other assignments do we have from your class then? Because it has like Cindy said that we're not doing like 1.2 and all that, so we do still have 4.1, this one, and then 4.3.
Yes, and I think they all say the 25th, don't they? Which is before class. I think we kind of been all over the place with this. So we did parts of this chapter 2, but you're not really ready to do all of that even, I don't think, because you need to get through 4.3.
Right.
So I think what I should do is just push the due dates on all of the chapter 4 stuff to the 2nd. And then maybe we we can not do some of them. I don't, well, we'll see. How, does that sound okay if we push that all to the second? I think
Yeah,
I'm just,
I was just not
Yes.
understanding like if this was gonna be due and we don't know what we're doing and stuff
oh,
like
yeah,
that.
yeah, yeah. No, we don't want to do that. I think,
Okay.
let's do this. Let's get rid of the chapter, or the project 1 for chapter 4. So that we'll get rid of. And then we'll leave all these 3 worksheets as practice on the table that maybe we decide to do, but we'll move it to, what's up? The second. It's in the car somewhere, but you gotta put clothes on if you're gonna go outside, okay?
And are we doing the 1.2?
No, I think that's already deleted. I think that's already
Oh,
gone.
I still see it, but that's fine.
Oh, how is, you must, wait, I must be in it. Are you in the I3 class?
Yeah, I think I
Okay.
am.
Okay. So let's write this on screen while I'm recording so that we can all have a clear thing. So what this means is there's essentially nothing due this Sunday for 133. Other than maybe your MyStatLab work, but that's for 033 anyways. So what we're gonna potentially turn in is that 4.1 worksheet number something, I think it's 2. 4.2 worksheet number something, and the one we were just, that was 4. And we're gonna look at a 4.3 worksheet number something, and then the chapter 4 review, and then the chapter 4 project 2. And that's it, but we're gonna push those all to October 2nd. So it's 4.3 number 2. And we'll evaluate on Monday. We'll probably do these 3 worksheets in class on Monday. And then this chapter 4 review will become like your homework thing. That's your practice, just like chapter 3 review was your kind of homework practice quiz, test yourself that you're doing it, and then ask questions, ask as many questions as you need.
Chapter 3 review is due this weekend, right?
That, I guess, yes, I guess that's the one that is due on the, this says the 26th. I think we must have said the 26th so you could bring more questions on Monday if you need it. And do remember that the due dates are to keep you on track. If you miss them, that's okay. You're not going to get penalized for missing them.
Can I see your chicken scratch one more time?
What? Yes. Yes. So we're going to say that these 4 are all, if they are going to be turned in, they're going to be turned in on the 2nd. And if we feel we need to not do all of them, we'll make that decision on Monday. Okay, good. So let's, I think part of the chapter 4 project 2, 7 and 11 through 16 is because we need to finish the notes for chapter 4. Let me double check. Yes. So this is a 4.3, number 7. And then, yeah, you could actually do these. So here you're just going to make up a length for your forearm, like actually measure it if you want, or make up one. That is going to be an X value. So that's an X equal, and it's the problem we just did. Plug this X into your equation and solve for Y for number 12. So your job is to figure out what is Y hat using the equation. And then 13 and 14, wait. Yeah, and then 13 and 14 is 4.3 stuff. That's the residual. 15, here we now have a Y value equals 12.7 centimeters. Predicted, so you could probably do that one. And 16, you might be able to, but some of this is we just need to finish chapter 4 notes. That probably doesn't help much, Brianna, I realize. So don't think that I think that was helpful.
So we'll go over this once we finish our notes and stuff on Monday. Okay.
Yes, I think that's what we definitely need to do. I think we've got a good start here. You all seem to be doing really well with the slope and reading the correlation stuff, but then let's do this. So we're going to work on this. What is that? 9:25. We will work on finishing up all of this.
What about the last page of 3.4?
Let's do that right now. So that was page 510 here. Okay, what questions you'll have?
I'm still having a hard time sorting out all the words. Like I have 2 highlighters here.
Nice. Okay, so how about I do my reading thing. Uh-oh. Just put shorts on. So first, note that there have been 59 presidential inauguration addresses in U.S. history. What does that tell us? Nailed it, LaShawn. Love it. Yes, this is a population because this represents all of the inaugural addresses that have ever been given, all 59 of them. Second, next thing is here we are working on a percentile. This is a percentile graph. And so on this side, it's a percentile, so it's a PK. And then the x-axis is how many words were in the address that these, well, we can say gentlemen, all these gentlemen delivered. And then if you look at this little box, here's a set of parameters. Anyone remember why I called them parameters? For example, if I were to label them, I would do mu equals 2335. I would do sigma equals 1374, and that capital N is appropriate. They're called parameters because, oh, wait. Standard deviation is the second one. Yeah, good. All 3 of these are called parameters because they're calculations done from a population. This is an ogive, I think is how Cindy pronounced it. I don't know how to pronounce it. I'm going to go with what Cindy said. I'd believe her over me on that for sure. Okay, so then we're told here Abraham Lincoln's second inaugural address, delivered in 1865, is widely considered the greatest ever given. Doesn't matter. We don't need any of that information. It was 700 words long. Notice that corresponds to an x-axis. What we're trying to find is this, so y-axis value. So what's helpful here, I think, is to recognize what's the scale on this. 0, 1,000, 2,000, 3,000, etc. So these are the word lengths. 701 is going to be like somewhere right here. Do we agree on that? Maybe. And then your job is to figure out what is that percentile. This first line is 10. So it's a number between 10 and 20. I might say, based on how I drew it, I might say that's the 12th percentile. Or we could write it as P12 equals 701. How do we feel about that?
When I read it on my own, I have trouble, but when you explain it and highlight and underline and point, I understand it a lot better. But doing it on my own is still difficult.
That's okay. That's because you're learning it. I mean, you're just making me feel good that my explanations are clear, but you'll get to the point here as you practice this underlying stuff and the reading part. You'll get there. If you already knew it, you wouldn't need to take the class. Although you might argue you don't need to take the class anyways, and I get that, but you know, we all have to jump through hoops. Okay, so now here comes Calvin Coolidge. We don't care about any of this stuff. All we really need to know is this word right here, 90th percentile. And then we're like, so how many words would it have? So your job is to find the 90th percentile up here. It happens to be this line. This is the 90th. And so we just follow that line over and say, okay, here's where it intersects. How many words does that look like? That is not a vertical line. Fail, fail, fail a lot, but that's the idea. How we could write this symbolically is P90 equals, and then we just put in our guess. It's really close to 4,000, right? 4,100? Do we feel good about that?
Yes.
All right, you all tell me C while I get more coffee. You're doing great, girlies. All right, what do y'all got? Anyone want to type your sentence in here in the thingy, the chat, or you can just say it. Or do you all have no clue? That's cool to say too.
I'm trying to find is there a sentence for this?
There is. It's in 3-5.
Okay.
And it's, here we go. It's page, oh look, there's the same graph. It's page 101. Either one of these options is a good sentence structure option. Love it, LaShawn. That is beautiful. 59% of US presidential inauguration addresses were at or below 2251 words. Yep, that's perfect. I guess I should type that in here. 9% of, I'm just going to shorthand it, addresses, even though we should really say inaugural, US presidential inaugural addresses, whatever. Were at or below 2251 words. Good. How many of you know the Z-score formula? Because if you know that, you can combine the formula with the mean, the standard deviation, and the data value, those three things. And you can get George's Z-score. Love it, Brianna. That's it. X minus mu divided by the standard deviation. Come on, man. So 135 minus 2335 divided by 1374. Note 2 decimal places. It's a negative something. Negative 1.60, is that what y'all got? I'm not giving you all much time to work on it because we're close to the end here, unfortunately. So is that number unusual? Is this thing unusual?
No, because it's not more than 2 standard deviation, or it's not like more than 2 or whatever.
You were right. It's not more than 2 standard deviations away from the mean. We can be a little more specific. We can say, no, it's not less than negative 2 standard deviations away from the mean. But that saying that it's not more than 2 standard deviations away from the mean is perfectly fine. Another way you could say it is you could say negative 1.6 is not less than negative 2. Most common mistake I see students make is when they see a negative Z-score, they say, yes, it's unusual because it's negative. Forgetting that negative Z-scores are perfectly acceptable. They're quite common. It just means they're smaller. They're below the mean. The threshold is negative 2. Is it below negative 2? Then it's unusual. Is it above positive 2? Then it's unusual. So unusually large versus unusually small. Remember that this Z-score thing too is only true if we have a symmetric data set. If it's not symmetric, then it's not true. And we don't actually know the distribution of this data set. It doesn't tell us anywhere. Okay, how we doing, y'all? So I think this worksheet is due this Sunday, right? And I need to apologize. I have like 13 assignments I have to grade for you all. I've got, things have not been going well for me in terms of grading. Mostly, I kind of don't feel as concerned about it because I expect everyone to have 100% because we do them all in class, right? But that's still not good that you haven't gotten feedback. Let's see, E. What do you mean? What do you mean, Brianna? I'm not sure I understand. what you're asking.
I think she's saying that we're viewing the Z-score from D.
Oh,
For E.
yes, yes. We calculated the Z-score here, and then that's George Washington's Z-score. So we're using that to determine, is it unusually low? And maybe I shouldn't have used the algebra. I should have said no. The Z-score is not less than -2. And so it's not unusually low. Okay. Unfortunately, I have to go to my next class.